Advanced Algebra Chapter 8, Lesson 5, and in the next video I want to look at solving logarithmic equations. And again, there's a number of examples. You only need to watch what you need until you feel comfortable with the material. There are two important examples in the video that you'll need to fast forward to if you're going to do that, to make sure you get some kind of nuanced things that will help you hopefully in solving the logarithmic equations. Some of them, because it's a pre-calculus video, are a little bit more complex than what we'll be doing, but the concepts are the same, and you can learn what you need to do by watching these videos. So again, take the time to watch what you need to make sure you understand, make sure you watch the two important examples, and then go ahead and tackle your sample problems. Chapter 3, Lesson 5 of Pre-Calculus, we're going to do some examples solving logarithmic equations. As a reminder, remember. That really makes a lot of sense, doesn't it? We want to remember that there's two things that we have to do when we're trying to solve for a variable. We have to isolate that term that has the variable in it, and then as a last step we have to use the inverse operation that undoes that. And we've been talking about logarithmic equations or logarithmic functions being the inverse of exponential, and we've talked about and done some examples where we had exponential equations and then we've done the inverse by taking the logarithm in order to solve it. In this video we have equations where the variable is part of a logarithm. So we're going to need to isolate a single logarithm and then do the inverse operation, that is change it to exponential. Basically what it comes down to is something we've done earlier, where once we have a single logarithm we evaluate it by changing it into its exponential form. Now in these examples that we're going to do, we have multiple logarithms, so we're going to have to apply those properties of logarithms that we've talked about, get it down to a single logarithmic term with the variable, and then do that inverse operation at the end, changing it to its exponential form, then to finish off solving for the value of the variable. Okay, a lot of introduction kind of stuff there, but let's go ahead and do some examples, and hopefully it'll become more clear to you as we do these examples. Okay, we're asked to solve these equations. We're going to round it to the nearest 10,000, so that would be the fourth decimal place. So let's go ahead, I'm going to scroll down here so we can see the answers first before we begin to do those, so we can kind of figure out or make sure that we get where we need to go. Okay, as we've talked about, in order to solve for the variable, we need to know, we need to isolate. So here's my term that has the variable in it. However, I have multiple logarithms, and in order to evaluate a logarithm, we can only do it with a single logarithm. So we're going to apply the properties of logarithms first to get it down to a single logarithm, and then we're going to do the inverse, change it exponential. So because this is a plus, I can use the product property and change this into x times 4, or 4x is equal to 1. So I apply the property that gets this down to a single logarithm. Now that I have a single logarithm with a variable term in it, now I do the inverse operation, which is to change it to exponential. So remember, this logarithm word, we can kind of verbalize it by saying, what is the exponent of the base? Actually, we say what is the exponent, but we have the exponent over here on the right side. So we have the base is a 10. What is the exponent? Well, it's over here, it's a 1. So 10 to the first is going to give me this value here, 4x. So now you'll notice we have a simple equation where we divide by 4. So x is going to be equal to 10 divided by 4. We always reduce our fractions. So this is going to be 5 halves. I prefer to leave 5 halves. They have it as a decimal answer. Because it says rounded off to 4 decimal places, I guess that's why they do that. But 5 halves or 2.5, either way, I'll take one of those. Okay? Alright, so that's kind of how we do it. That's not kind of how we do it. That is how we do it. So let's go ahead and do some more examples, and maybe as we do some examples it will become easier for us to see what we need to do. Okay, so looking at number 2 here then, Again, I have 3 logarithms, 2 are on this side, 1 is on this side, and again, I have to get this down to a single logarithm using properties of logarithms, and the only way to do that is if all the logarithms are on one side. So I'm going to have to move this logarithm over to this side as step number 1. So we're going to do log of x minus log of 5, and then we're going to subtract that from both sides. Log of 33 is equal to 0. Now don't forget, you subtracted. This is equal to 0. It's an equation, so don't think because you moved it over here there's nothing over here. There is a 0. So now subtraction is division, so we're going to change it to a single logarithm, now applying the properties. So it's log of x, minus means divided by 5, and minus means divided by 33. So I have 5 times 33 down here in the denominator then, equals 0. Now that I have my single logarithm, I do the inverse operation, which is exponential, so I change this to its exponential form. So log is, what is the exponent of the base? The base is 10. What's the exponent? Well, that's the exponent over here. So this 10 to the 0 is equal to then x over, and 5 times 33 is 165. So now I have this simple equation. I can go ahead and solve it. 10 to the 0, or anything to the 0 power, is a 1. So 1 is equal to x over 165. Multiply both sides by 165. So x is equal to 165. So you see we have our answer here. Okay, so kind of a little thing there. Remember, this logarithm has to go to the other side. Then we use the properties of logarithms and get it down to a single logarithm. Then do the inverse operation of that, or the inverse function of that, which is change it to exponential. All right, we'll do a lot more examples. I don't know if that's the right way to say that or not, but that's the way we said it. Okay. Looking at number 3, then here I have 2 logarithms, so the property of logarithms is a minus, so it's the log of x. Minus means divided by 9 is equal to 1. Now that it's a single logarithm, the inverse function is the exponential, so I change it to exponential. Here, the log of base 10, so what's the exponent of 10? And that exponent that was over here, 1, that will give me x over 9. Okay, so then I solve this equation, multiplying both sides by 9, so x is equal to 90. All right. Doing number 4 then, 2 exponents, we're going to need to get it down, our logarithms, we'll get it down to a single logarithm. So 9 plus means multiply, so 9x is equal to 1. Now that it's a single logarithm, the inverse function is the exponential, so what's the exponent of 10, which is over here, so 10 to the first power is equal to 9x. So x is going to be equal to 10 divided by 9, and then that's the exact answer. It says rounded off to 4 decimal places, so that would give me this. Okay? Alright, do one more kind of in the easy range, and then we'll kick it up a notch to something that's a little bit more difficult. Okay, for example 5, we have a logarithm on the other side of the equal sign, so we're going to need to move it to the same side so we can apply the properties and get it down to a single logarithm. So we're going to subtract that log of 48 from both sides. And again, remember that equals 0. Now we can apply the properties of logarithms. So I have x, minus means divided by, another minus means divided by, and that equals 0. Alright, so we have then a single logarithm, so we do the inverse function, which is exponential. So here the base is a 10. This is the exponent of 10. That is going to give me this value here, and we multiply those together, 192. Now, 10 to the first power is a 1, so 192 multiplying both sides by 1, so x is going to be equal to 192. Alright? So in these next examples, it gets a little bit more difficult because we're not going to use log 10 all the time. So we're going to use a different logarithm. We're going to do a different base, but the process is the same. Okay? We have multiple logarithms, so we need to get that down to a single logarithm. So it's base 7. So we have log base 7. We have 2x, and then plus means times 5 is equal to 1. Now that we have a single logarithm, we can change it to its exponential form. So we have the base here is a 7. This is the exponent to the first power. Gives me then 2x times 5 is 10x. Then I simply solve this, dividing by 10, so x is 7/10. Okay? So it's really no different. Different base just gives us a different value that we're going to have to solve for. All right, looking at number 7. We have multiple logarithms. Now remember, these parentheses are very important that we hang on to those as we go forward, so just keep that in mind. So the logarithms are on one side, so we can go ahead and get them down to a single logarithm. So we have 8, and then a plus sign means times, and then we have x minus 4 is equal to 1. Now that it's a single logarithm, we undo it by doing the inverse function, which is exponential. So the base is a 4. The exponent is a 1, and that 4 to the first power is going to equal 8 times x minus 4. And now we have a nice equation that we're used to solving. So distributive property, 8x minus 32. We're going to add 32 to both sides. So 8x is equal to 36, and so x is equal to 36 divided by 8. Both of those divisible by 4, so that gives me 9/2. And that's my answer. Okay. All right. So let's do some more. Okay, we'll continue to do these. Hopefully you're getting the hang of those. Hang of these. Okay, again, here we have an example where we have a logarithm on the other side. So we're going to need to get that to one side so that we can apply the property. So we're going to have log base 9 of negative 5x minus log base 9 of 2 minus log base 9 of 20 is equal to 0. So now that this is all on one side, we can combine or use our properties of logarithms to get it down to one logarithm. So this is log base 9 of negative 5x. Minus means divided by 2 divided by minus is 20. Is equal to 0. So now that I have a single logarithm on this side, I can do the inverse operation, which is exponential. So log, what's the exponent of 9? Or 9 to this exponent, 0, will give me this value right here, negative 5x over 40. Okay? Now, 9 to the 0 power is a 1. Okay, so we're going to multiply both sides by 40 in order to undo this division. So 40 times this 1 is going to be 40 is equal to negative 5x. So x is going to be equal to negative 8. Okay? And we have our answer. Okay, let's look at number 9. Alright, the logarithms are on one side, so we'll use our properties and get them together. So log 9 of x minus means divided by, and then I have x minus 5 in my denominator is equal to 1. But forgot log base 9 here. Now that it's a single logarithm, the inverse exponential, so the base here is 9. The exponent over here is a 1. 9 to the first power is going to give me this x over x minus 5. Now again, we've got some fun algebra stuff to do. Remember, that stays together. So I'm going to multiply both sides by x minus 5 in order to get that x minus 5 out of the denominator. So then I'm going to distribute. I'm going to get x's on the same side and then divide by that. So x is 45 over 8, and that doesn't reduce, so we have our answer, 45 over 8. Alright? Okay, I'm going to do one more kind of on the mid, as far as easy goes, and kind of a medium, and then we'll start with the more difficult ones. Okay, looking at number 10, the logarithms are on one side, so we'll just go ahead and apply the properties. So we have log base 6 of 3, plus means times, and then I have another number, x plus 10 is equal to 2. Now that I have a single logarithm, inverse operation is exponential, so I have a 6 to the second power is going to give me this value right here. And now we solve. squaring both sides, and then we're going to subtract 30 from both sides. 6, so x is going to be equal to 2. Alright, and we have our answer. Alright, on number 11 here, we have a natural log, so we're going to remember that that's base e. We have one logarithms over on the other side of the equal sign, so in order to use the properties and get them down to a single logarithm, before we can change it exponential, we need to have everything on one side. So we're going to move that over to one side. So I'm going to have natural log of this value plus the natural log of 7, and then minus the natural log of 5 is equal to 0. Now we can apply our properties. So we have 2 minus 3x squared. Plus means times, so it's going to be times this 7. Minus means divided by this 5 is equal to 0. So now that we have a single logarithm, we're going to change it to its exponential, or do the inverse of that. So the base here is e, and the exponent is 0. E to the 0 is going to give me this value over here. Alright, times 7 divided by 5. So we're going to multiply both sides by 5, and this is a 1. E to the anything, or anything to the 0 power is 1. So that's going to be 5 times 1. And we're going to distribute this 7. Alright. And then we're going to solve for x. Now, this looks like a quadratic. It is a quadratic. And there's no linear term, so we can do extracting the square roots. Simply meaning we're going to solve for x. So I'm going to move this 21x to the other side so that it's positive, 21x squared. Subtracting 5 is going to give me 9. So I'm going to divide by 21 first. So 9 over 21, which reduces, I'm going to simplify that first, dividing both by 3 gives me 3 over 7. Now to solve for x, I'm going to take the square root. Now remember, because we're taking the square root, we're going to end up with plus or minus, and that's going to be the square root of 3 over the square root of 7. And I need to rationalize my denominator. I don't want to leave a square root in my denominator. So that's going to give me plus or minus the square root of 21 over 7, which you can see is the answer that we have up here. Okay? So the only thing here really that makes it a little bit more complicated is base e, so remember that, and then you might be dealing with some quadratics, so you'll have to remember how to solve quadratics. If there's no linear term, it's pretty easy. If there's not, then you'd have to factor it, but you can still do that because we all know how to do that. Okay, so a few more examples then. Really? Okay, number 12 here, again, we have a natural log on the other side, so we're going to have to move that to the same side so that we can apply our properties. So this is going to be minus natural log of 11 is equal to 0. So again, now we have the natural log of 4 minus x squared. Plus means multiplied by, minus means divide, and again is equal to 0. We have a single logarithm. Change it to its exponential, inverse operation. Base e to the 0, anything to the 0 power is 1. So that's going to give me this 4 minus x squared times 9, all of that divided by 11. So we'll multiply both sides by 11 and distribute. So this is 36 minus 9x squared. And again, we'll solve this. So I'm going to move the 9x squared over here. I'm going to move this over here. And then we're going to divide by 9, 25 over 9, which does not simplify, so we'll take the square root. And because we take the square root, it's going to be plus or minus, and we'll 25 square root of 9. We have a nice little perfect squares here, so this is going to be plus or minus 5/3. Okay, and you can see that's what we have here. All right. I'm going to do a couple more examples, and then you can watch again as many as you find necessary. All right, I have a natural logarithm over on the right here, so I'm going to need to move it to this one side so that we can apply our properties. All right, so we have this. So we have natural log then of 2x squared plus 6. Minus means divided by. And minus means divided by equals 0. now that we have a single logarithm, inverse operation, exponential, so we have base e to the 0 again, which is going to give me 1, is 2x squared plus 6 over 4 times 26, which is what? 80 and 24, 104. Okay, so we're going to multiply both sides by 104. We're going to subtract 6. We're going to divide by 2. And then we're going to take the square root, which is going to give me plus or minus 7, which is what we should get. Oops, that one didn't work out. But you guys get it. Okay, 2 more examples. Okay, number 14 here, we have another logarithm on the right here, so we're going to need to move that to the other side, so everything's on the one side. So we're going to have this minus natural log 36 is equal to 0. And now that they're on one side, we can apply our properties. So 5x squared minus 7, minus means divided by, and then minus again means divided by, equals 0. Now that we have a single logarithm, we change it to exponential, so the base e to the 0, but anything to the 0 power is 1. So we're going to have 1 is equal to 5x squared minus 7 over 8 times 36, which is 288. So we're going to multiply both sides by 288, so we're going to get 5x squared minus 7 is equal to 288. We're going to add 7 to both sides, which is going to give me 295. We're going to divide by 5, which is going to give me 59, and then we're going to take the square root, which is going to give me plus or minus the square root of 59, which is a prime number, so that is simplified. Okay, it's kind of the same problem. The logarithm's on the other side, so we're going to need to get it all on one side so that we can apply our properties, get it down to a single logarithm. Ooh, this one looks fun. Alright, so again, now we apply our properties, so we're going to have x plus 5. Minus means divided by, and then minus means divided by, equals 0. So a single logarithm changing to exponential, so we're going to have e to the 0, which is 1, is going to equal x plus 5 over 12 times x minus 3. Alright, so again, this is 1. We're going to multiply both sides by 12 times x minus 3, so it's going to equal x plus 5. We'll go ahead and distribute this now. We could have done that distributing earlier. I just kind of waited till the end here. So we're going to move this x over here is going to be 13x. We're going to put this over here as 41. Whoops, that's not going to be 13x. It's going to be 11x. 12x minus, so that's going to be 11x is equal to 41, and then dividing by 11 is going to give me 41 over 11, and I have my answer. Alright, so that's how you do logarithmic equations. Hopefully that was helpful for you, and that'll wrap up our solving equations lessons.